Part 2 of Section 8, the measures of central tendency. So mean, median, mode, and range. We're going to get into mainly mean, median, and mode right now, but I think it's important to know all of them. So the mean is the average, which I think is something that we deal with a little bit more. And remember, that's taking, if you add them all up, add them and divide by the total. Right, that gives you the average, which we also call the mean. Median, if you put them in order least to greatest, it's the number in the middle. Mode is the number that appears most often, and it is possible to have no mode. And the range is the difference between the largest and the smallest amounts, right? So you would just subtract because of the word difference. So getting on to page 62, there you have a value or the definition of median there. And they tell us we have, this is the same 10 deaths ages that we talked about in the first video. So calculate the median age, and there's a couple ways that you can do it, but notice first how the numbers are in order least to greatest. So this is kind of how I go with it. I say, okay, I'm going to take one off each end, and I just go ahead and kind of work my way in. So when I do that, eventually you'll see in this case we have two numbers in the middle. So if I have two numbers in the middle, then I want to know what's exactly in between those. And to do that, I find the average of those two numbers. So I would take 34 plus 46 and get 80. And because there are two of them, I would divide by 2. So the median for this piece of data is 40. And how does that compare to the average we found on the previous page or the previous video? And if you remember, if you added all these up and divided by 10, we ended up with 37.7 on that previous page. So the average is actually 2.3 less than the median. So you'll notice that the mean and the median are very rarely the same. They could be, but it's not very likely. So when you look this next piece of data, which is just kind of fun, we say, you know, a rut row, what if that last number should have been an 84 instead of a 76? Well, how does that change things? So to find the mean, right, remember we're going to add them all up, so add all these numbers and divide by 10. So when we add them all up with that 84 there, we get 385 divided by 10. So the average is 38.5. Well, when you're finding the median, you know, with the median, we don't have to, it doesn't matter what the numbers are, it's more of the order. So with the median, we still have 34 and 46 as the two numbers in the middle, so we would still take 80 divided by 2. Our median is still 4. So notice how the mean, when the numbers change, the mean changes. It actually increased by 0.8. But the median, because the median is more of where the numbers fall on in the descending or ascending order, our median didn't change. So that's something to pay attention to. And here on the bottom of page 62, this chart here is super duper important, this thing right here. Because there is a relationship between the mean and the median, and it tells you how your data is, basically can be graphed. So when we talk about a symmetrical, so symmetrical is this first one here. And it means kind of you have the same amount on each side, right? If you fold it in half, the left and the right side are identical. However, skewed right and skewed left, we have more data on one side than the other. So when we say skewed left, that means the tail goes off to the left. Most of our data falls on the right. So skew left means tail to the left. If we say skew right, that means our tail goes to the right. And you'll notice that if it's skewed right, that means the mean is larger than the median. And if it's skewed left, the mean is smaller than the median. You don't have to have those memorized. Just know where to reference it if we get to a homework problem that asks about it. So we'll talk through questions 1, 2, and 3. Normally we expect the elderly to die, but not the young. Since more elderly people die than the very young, is age at death skewed left or right? Well, let's think about this in terms of a picture. If we, okay, so like let's say the 40-year-olds are here and the 80-year-olds are here. Well, we would expect a lot of 80-year-olds to die, right? So that part of the bump would be up here. Well, the 100-year-olds, right, there's not very many around, and right, generally it goes down. Yes, 4-year-olds do die, but not very many. So because we have this tail going this way, we would say this is skewed left. All right, just thinking kind of through it, I guess I would say logically to an extent. Number 2, patrons at an amusement park. Well, I would think there's not a whole lot of like 4-year-olds there, and probably not a lot of 80-year-olds there, but I bet there's a lot of teenagers. So this would be, little, and then up, and then it kind of tails off. We might have a couple adults, right? They might be chaperoning, but not a ton. So because, again, we're tailing off to this one would be skewed. Well, it's tailing to the right, so we would be skewed right. And what about the Olympic volleyball players? Their heights. Well, I don't know about you guys, but when I look at the heights of volleyball players, I'm always quite impressed because they're super tall, right? Nobody like me at 5'4" is there, so short people, not very many, and then we get super tall people. So, again, we are skewed, and in this case, it would be skewed left because the tail goes to the left, right? Lots of tall people. All right, the mode. Okay, mode is the number that appears most often, but something I need to point out first. When you look at these data, right, there's 15 numbers here. They are not in order. So when you've got to find the median, we need to put them numbers in order first. So the first thing you got to do is rewrite them. So I want you to hit pause on this video in your packet, put them in order, least to greatest, and then go ahead and try to find the mean, median, and bone. Answer these questions. Okay, so you might see, sometimes I think it's easier to write numbers like right underneath them because then you can make sure that you didn't miss any, right? If you miss one number, it's going to jack up all your answers. So I wrote them in order there, and then I look at what I got. And I don't know about you guys, but I noticed there are 4 8s. Because there are 4 8s and there are no other numbers that are there 4 times, that is my mode. Median, we got to go to the middle. And I'm guessing that you notice this. Let me change colors to get a little excited. Let's go to blue. So when I say, okay, I'm going to cross off 4 over here, 1, 2, 3, 4. Let's go 1, 2, 1, 2, 1, 1. Boom! I've only got one number in the middle, so that's my mode, or that's my median. Ooh, sorry about that. Now when I'm trying to find the mean, I got to add them all up. So if I add all these numbers up, I get 103. There are 15 numbers here, so divide by 15, and that's how I got 6.87. You'll notice that your calculator is actually going to spit at you 6.86666, and it goes on and on and on and on. I went ahead and rounded to the nearest hundredth because, let's be serious, that's a lot of numbers. So, all right, let's go to page 64. I would like you to hit pause, and I want you to work through the rest of this page and then come back and get the answers because it's more of what we just did. So hit pause, do it, come back. Put them in order. The mode is a 3. It's there 5 times. The median is 3. It's 15 numbers, and 3 is the number right in the middle. When you add them all up, you get 51. Divide it by the 15 numbers you got, and your mean is going to be 3.4. Because the mean is greater than the median, right? Mean is greater than the median, it is skewed right. You get that from the previous page. At the bottom, 7 and 8, so 7, the mean, when you add them all up, you get 1476. Divide by 9, you should get 164. And the median is 186, even though that's horribly written. 186, so the median is greater than the mean, so that one's skewed left. And if we change the smallest number, so if we would change 160 to something smaller, would the median change? And that answer is no, because the median doesn't care about the numbers, it only cares about the places of the numbers. So if we would change this 160 to 140, it doesn't change where the numbers are, 186 would still be in the middle. Would the mean change? Yes, because if you change the number, it changes the mean. Right, so make sure you do that. One thing I want to point out real quick is this dot plot here in the middle of the page. I think it's actually number 6. But when you can see that the highest bar is here, and there are 2 numbers over here, and there are 4 over here. So this would be a longer tail, so this one would be skewed right. So you can kind of get a pictorial view of that too. So, all right, that's the second part for section 80, or yeah.